Okay, hi guys. So we'll go through the 2024 Leaving Cert Maths Paper 1 here, so higher level as well. So we'll just go through solution for it. It's a very easy exam, to be honest. Very easy exam. So we'll go through the solution for it. So it would have been quite fair for a lot of people. Right, so all we do here in part A is we square both sides. So you start off with n minus 3 squared equals 3n plus 1. Then this becomes n squared minus 6n plus 9 equals 3n plus 1. And then it's n squared minus 9n plus 8 equals 0. Factorize that, it's n minus 8 times n minus 1 equals 0. N equals 8 and n equals 1. Both are natural numbers. That was fine. Nice question to start the paper. Express this as a single fraction. So you want to multiply above and below by the other person's denominator. So this guy here, so this here will be 4 times 12t. And then this guy is going to be minus 7 times 2t plus 1. And then they're all over this common denominator of 2t plus 1 times 12t. And then tidying up the top, you get yourself 48, take away 14, that's 34t. And then you have a minus 7, and there's no need to multiply at the bottom. It's neat or not multiplied out. And that will be that, because it's a single fraction now, as they want it, and it's in terms of t. Okay. Moving along. Yeah, this is easy enough simultaneous equation. It just, to kind of spot the right thing to do. So if you just get rid of y in the first two, then you just have two equations with x and w in it. So best way to do this, maybe multiply the second one by minus 2. So then we have the top one stays the same, 2y. I'll leave a bit of room there, equals 143. Multiplying this one by minus 2, so then it'll become a minus 2y, minus 6w equals, that's gone multiplied by minus 2, so it goes to 148 now. So it does. You draw a line underneath them, plus symbol to tell the examiner you're adding them, and you get x minus 6w equals 291. Yep, 291. Okay, so that's a new equation now. So what we'll do now is we'll then take maybe that bottom one there. We'll take this guy actually and multiply him by minus 4. So then we get minus 4x. Yeah, or what's the best way to do it? Yeah, I'll actually, the way I have it done here in the copy, I'll stick with that. I multiplied him by 4, so that's 4x minus 24w. And this fella by 4, which is 1164. Let's double check that. By 4, yeah. Then I multiplied this bottom one by minus 1. So that's a minus 4x minus 5w equals minus 4. Draw a line underneath them, add them. Minus 29w equals 1160. Then w equals minus 40. Put your minus 40 in there. So you're putting minus 40 in here. I'll bring it over as well. So it's equal to 291. And then it's plus 6w. And then you put your minus 40 in there. And then x equals 51. And then you want to get a value for, what's the missing one? Missing one is y. And sure, you just put your value of w in there. So y equals minus 74 minus 3w minus 3 bracket minus 40. And then that has y working out as minus 74 minus 3 multiplied by minus 40. So it's 46. Yeah, and they're the correct answers. So I checked them on a thing earlier. simultaneous equation solver. So there are your values, easy enough. Okay, question 2. This very handy question 2 to start off. You literally just use the minus b formula on this guy. So z equals minus 12 plus and minus square root 12 squared, which is 144, minus 4 bracket 1 bracket 261, all divided by 2. Now, that'll give you an error if you type it into your calculator because this thing's negative. If you type that into your calculator, just the inside of the square root, minus 4 multiplied by 261, you get minus 900. So the root of 900 is 30. So the way this works is minus 12 plus and minus 30i. So root minus 900 is 30i over 2. So your answers are minus 6 plus and minus 15i. All done in a minute. Cool. Next one's the Moivre's theorem on this. So people would mess up here and not converting it into polar form correctly. What you want to do is you always want to plot these things first. Which quadrant is he in? He's in this quadrant here. What's the rule for that quadrant? It's 2 pi minus theta. That's from your trigonometry. So what you do is you get the first quadrant angle by going tan inverse, everything positive. See, I've kept all the coefficients positive. That works out as, make sure your calculator roll is in the Algebraic mode. That's pi over 3. So the actual theta that you'll be working with is 2 pi minus that, which is 5 pi over 3. Yes. 2 pi minus pi over 3. 5 pi over 3. And then your r is the square root of, your 1 squared plus your root 3 squared, which is just 3. And then r is working out as 2. So then your complex number is 2 bracket cosine that angle, 5 pi over 3, plus I sine 5 pi over 3. And what you should do as well is you should just kind of, multiply that out there and see that you get back to 1 minus 3 root 3i. And you know you've done it right. So all you got to do now is raise to the power of 9. Z to the 9 equals 2 to the 9, and then bracket cosine. If you multiply this in here by 9, the 9 and the 3 attack one another and leave just a 3, so that works out as 15 pi in there, and then you have a 15 pi in here. And you can do them in your head because you can take 2 pi's away from this. It's the same position. So it's, what's the value of cos pi? Well, it's minus 1. And what's the value of sine pi? It's 0. So that's plus 0i. And that's multiplying by this guy, which is 512. So your answer is minus 512. And you could just type them into your calculator. Tell you that that's minus 1 and then that's 0. So that's all good there. Cool. Yeah. So we'll move on. Yep. Minus 512. Yeah, so I've done a bit of this here. We'll leave the diagram in there. Saves me sketching it. Yeah, no, I'll build it up. It's nicer. Build it up. So if we look at this here, plot this number here. There's 2 ways of doing it. That's 30 degrees. So you could measure out a distance of 4 with your ruler and then plot 30 degrees. But at the same time, you can just multiply this thing out and write that u is equal to, if you multiply it all out there, it works out as, next page, 2 root 3 plus 2i. And then, because you'll need the decimal, you'll need this here for plotting it, plus 2i. So it's about here, come over about 3.5, come up to about 2, something about there is good. And call it u. Now this here is 0 plus 0i, so he's located there. And then you're asked then for this angle in the next part here, WOU. So what you do is you join these together, because this here is called O. And we're looking for that angle there in the middle. Well, look at this here. This is 2 and this is 2, so he has an angle of 45 there. It's just the way it is. Now, pi over 6 is 30 degrees. So I'll do this in degrees first, and then I'll do it in radians, which it's supposed to be in. So you take them away from 180, you see that that's 105. So what you can do then is you can convert that into radians if you want. The conversion is 105 multiplied by pi over 180. Or what you could do is you just say this is pi over 6, this is pi over 4, and take them then away from pi, which is the best way to do it, because 180 is pi. So you go pi minus pi over 4 minus pi over 6. And that gives you an answer of 7 pi over 12. So that's the answer. And that's in radians, so you can put rad at the end of that just to say it's in radians. Cool. Right, integral here. It's pretty simple. Very soft question. Integral of cos, it goes back to sine. Inside stays the same. You divide by 6 and you just add a plus c. That's all that was. So f of x here. Now this one here, do not simplify it, which is a bit funny. That's because they expected students to spend a bit more time on the part 3 here. You want the equation of the tangent, so that's a hint to go looking for the slope, because f dash x is the slope of the tangent. So you get yourself your f dash x there. And it's 6x squared minus 18x plus 5. And then you put 2 in there to get your slope at that point. 2. You want to show all the workings on the page like this for the examiner before you go picking up a calculator. Plus 5. You type that into a calculator. 6 minus 36 plus 5. Yep, you'll get yourself a slope of minus 7. Now you need a point, you've only an x value, so you need a y value before you can use the equation of a line formula. So you just get f of 2. And then again, you show your workings on the page. Minus 9 times 2 squared plus 5, so I'm putting back into the original f of x minus 11. I'll just type that in again. 16 minus 4 plus 10 minus 11. So I'm getting myself a minus 21 there. So that's like my y value. So my point now, the point is 2 comma minus 21 with the slope of minus 7. And this is what they mean, like you save a bit of time here by just going, you know, y minus y1, which would be a plus 21, equals m, which is minus 7 times x minus 7. And you can just leave it like that, you know, but it doesn't take much to move it over. So what is it? You multiply it out, it gives a minus 7x, bring it all to one side. This is a plus y. That gives a plus 14. You bring your plus 14 over, leave a plus 7, and have an equal 0. Very important, equal 0. That's grand. That's the answer to that question there in red. So I have it done in Desmos here. So we'll drag it onto the screen here. Okay, you can see that there. So there are your equations, and you can see the blue line is the tangent, and you see that's a tangent there at an x value of 2. So it does what it's supposed to be doing. Okay, so find the x coordinates, the point of inflection. That's pretty handy. So you just want to remember your f dash x was 6x squared minus 18x plus 5. Then you want to get your second derivative here and set it equal to 0. So that's your 12x minus your 18. Set that to 0. You'll see that x is 1.5, 3 over 2. Make sure to write it as a fraction. And they just wanted the x coordinate, so game over. That's fine. Didn't want the y value. Now, so again, I've done a bit of drawing here, so I'll build this up. This is a tough question for sure. Very confusing question. For sure. But, you know, the marking scheme will reflect it. And if you've done anything reasonable enough, you'll get close. Might only be worth 5 marks in the end. So hopefully people didn't waste 2.5 hours at it. Right, L dash x is a straight line. So its derivative will just be a value, a constant value. And you can actually work out what that constant value is. So the slope of L dash x here is you run 2 blocks and you rise 1 block. So his slope there is a half. So when you take a derivative of him, he'll just be like y equals a half, or L dash x would be just equal to a half. And that's going to be definitely marks in the marking scheme. So the student then could have went and plotted what L dash x looks like there in purple. Because it's a constant value is a horizontal line like that. So that's L dash x there in purple. Now, So the best way to do this question is p of x is a curve that varies like that. So what students could have done was they could have realized that the derivative of this here, its derivative graph will have a value as 0 around there at its turning point. It'll have a value as 0 here as well at its turning point. And it has a maximum value in and around there. And you know that slope there isn't a million miles off 2 or something, you know. And so students could have drawn maybe something resembling, you know, maybe that. Something like that there, okay? And then you could have read off x values from that. So it looks like they're crossing there at 2 and they're crossing there at 7. Okay, that's one way of doing it. What's the better way, and the way they wanted to see could you realize this, is um, this is saying his slope equals his slope. When does that happen? So this guy has a constant slope of a half. So you're really just looking at this p of x curve and saying, where does the slope equal a half? And in other words, it's where is it parallel to this line here? And so I'm just going to draw this line here. And I'm going to just move it onto this here. So she's parallel there for sure. And then I'll do another one then. So this has been the way the majority of people would have answered it. So we can see the x values that's happening at is 2 and 7. And so your answers to this here is x equals 2 or x equals 7. So it's basically you're just looking for where on that black curve does it have a slope, tangent slope parallel to L of x, because their slopes are equal there. So it's at 7 and it's at 2. Cool. Tough question. What do we got there? First principles, very, very easy stuff here. The only place you'll be losing marks here is if you're not writing the limit as h tends to 0. So first of all, you work out your x plus h, which is x plus h squared minus 7 bracket x plus h minus 10. This equals x squared plus 2xh plus h squared minus 7x minus 7h minus 10. So your formula, f dash x, and you have to say it's equal to limit x tends to 0 all over this fellow up here. I'll write it out, very boring. Plus h squared minus 7x minus 7h minus 10. Take away f of x. It's good maybe just at the very start here to have told the examiner what the formula is, you know, limit h tends to 0 of f of x plus h minus f of x all over h, you know. Take away this fella, so it's minus x squared plus 7x plus 10 all over h. The x squareds are gone, the 7x's are gone, the 10's are gone. And we're left then with just things with h in them. So you have to keep saying it. Limit as h tends to 0, f dash x, because you lose marks if you stop saying it, because it's not technically the slope without that thing there. So it's 2xh plus h squared minus 7h all over h. Now, what I'm going to do is I have to say it once more. H tends to 0. And then this here is, I've divided in by the h, so there's no divider line. So it's going to be 2x plus h minus 7. And then this will be equal to, I'll let the h be 0. So then you have 2x plus 0 minus 7. And so your answer is 2x minus 7. And you can confirm that's the correct answer because you do, multiply down by the 2, you get 2x minus 7. Cool. Easy marks, very easy. This was a tough one. It's a quotient rule, but it's a pretty involved quotient rule. And then you have to sub the value in. So a lot going on, a lot going on. So you call your u equals 6x plus 1. But it's easy to pick up marks in a question like this. You just be neat. du dx is 6. dv dx is 4x cubed. Go to your formula tables, get the formula. It goes v, and v is this fellow here, x to the 4 plus 3 times du dx, which is 6, minus u, 6x plus 1, times dv dx, which is 4x to the 3, all over v squared, which is x to the 4 plus 3 squared. Now, you don't waste any time tidying that up because you're about to put a value in for it. So what you'd write then is you'd write this before you go messing around with your calculator. You need to put the value in. So brackets, or no, just a bracket on top. Bracket minus 2 to the 4 plus 3 times 6 minus 6 bracket minus 2. So like this is going to be max attempt marks when it's written. So that's why you always write it all over. Bracket minus 2 to the 4 plus 3 all to be squared. Now, you pick up your you don't get, if you multiply them out, you don't get any more attempt marks. That's it. That's the answer. So you just have to type that into a calculator. And if you do that, you will get a value. You get a value of minus 238 over 361. And I typed that into a derivative calculator, the original function on the internet, and I put the x equal minus 2 into the derivative and got that number, so it's definitely right. This one's a good one. It's a good one, bit of thinking here. So the words there in bold is what makes this question easy. So local minimum. So don't mix up a local minimum with a global minimum. So a quadratic, when it turns like this, has a global minimum. That's a global minimum. Whereas a cubic has what's known as a local minimum here, because it's only in this local area. You see down here, it has values lower than the minimum there, you know. So it says here, h of x, the y value, must be at least 5 for all x values. And no, because this is a local minimum. And so you can see there's this part of the curve. So even if you just sketch this for the examiner, you know, and talked about it, the fact that, you know, there's this part of the curve here below the local minimum. So the main justification here is this here is false, first of all, and it's because it's only a local minimum and not a global minimum. If it was a global minimum, then absolutely yes, it will be at least 5 or equal to 5. Okay, that's fine. So the diagram there tells us the story that we could be dealing with this scenario here. Sound? This was a nice question. There would have been loads of these in mock papers, you know. So arithmetic sequence. So the story with an arithmetic sequence is its common difference. D is always like the term after. Take away the term just before it. So D will be equal to T3 minus T2, but it's also equal to T2 minus T1. And so you just set them two things equal to one another. So that would be 6p plus 7, take away 5p minus 3. And that will be equal to 5p minus 3, take away the first term, 2p plus 1. And that works out as p plus 10 equals 3p. It's a minus, so that's a minus 4. So then my p come over, this comes over here, so 2p equals 14, p is 7. Handy enough. Now, this down the bottom, this is a good question. A lot of people will be scratching their heads on how there's two values. So this is a geometric sequence, and the formula for a geometric sequence is Tn, is in your tables book. So G7 is equal to a or to the 6. This one's a or to the 10. So 6 equals a or to the 6. 3 over 8 equals a or to the 10. Get a on its own, best way to do this. There's other ways, but this is the easiest way. A equals 6 over or to the 6. A on its own here is 3 over 8 or to the 10. Set them equal to one another. 6 over or to the 6 equals 3 over 8 or to the 10. Cross multiply, and you'll get yourself a 48 or to the 10 equals 3 or to the 6. Bring it all to one side, divide by 3. You'll get 16 or to the 10 minus or to the 6 equals 0. Factor out an or to the 6. Go bracket. 16 or to the 4 minus 1 equals 0. the ways this is 0, if is or is 6 or is 0 from this here, but that's not a valid answer because, you know, or will be non-zero. So we'll throw that one away. So the other solution is when or to the 4 equals a 16th. And you get that by setting 16 or 4 minus 1 equals 0 and move it around. So you get that. So then you take a quarter of both sides, but you should be careful because it can be plus or minus 1 over 16 to the power of a quarter. And so the answers are plus and minus a half. So a lot of people wouldn't have realized the plus and minus because minus a half also gives a solution to this. Cool. So this was good. This is a smart question here. So we'll look at this one. So what you want to do here, write out a few derivatives. So f1 was equal to 2024 x to the 2023. f2 is equal to 2024 times 2023 x to the 2022. And just, you know, there's going to be a pattern here, so you definitely want to maybe write out another one just to see what's going on. 2024, 2023, 2022, x to the 2021. And just remind yourself as well, because you're trying to visually see something, so you want to write these things out. F0 was x to the 2024. And just to remind what the question is, you know, these are the derivatives, you know. Yeah, the function f of n is the derivative of the one just before it. Yeah. So in other words, f2 would be the derivative of f2 minus 1, which is f1. So f2 is the derivative of f1. So that's correct. Now, you can look at that for a while, and you could be smart enough to see that the formula for this, so I'll just write the formula down. You can have a think about why it is this. So fn, so there probably would have been a bit of marks going for this. This part 2 is difficult. Again, it might only be worth 5 marks in the marking scheme, so don't be worried if you didn't get it right. So I had a bit of a think about it, and my fn formula actually works out as 2024 factorial over 2024 minus n factorial. And then that then is multiplied by x to the 2024 minus n as such. And that's your fn like that. Okay. But it doesn't actually help solve the question too much, you know, but it's there. So the way to think about this is how does it go to 0? Like, how could it have a value of 0? So the thing they wanted you to spot was that if there's still an x and you take a derivative of it, there's still going to be an x. But if the x has, like, you see the x is reducing, so when the x is 0, it's x to the 0, that's a value of 1, so there's no x anymore. So if you take a derivative of that, then the value will be 0. So in other words, like the derivative of x to the 0 dx is 0 because that's a value of 1, you know. So if we have a think about it then, when you're on f2024 from this pattern here, you'll see that that's the one, you know, it'll have a load of numbers here or whatever, but that's the one that'll have x to the 0. And so it's f2025, that will be the one that's 0, because when you take a derivative of that, it'll go to 0. So n was equal to 2025 by my reckoning. Okay, so again, you know, it's only going to be worth maybe 5 marks if it was poorly answered. Good. And then you'll get some attempt marks for trying things. Okay. So, question 6. Very easy. X minus 4 is a factor. Factor theorem says that x equals 4 is a root, which means you can put it in. The thing will equal y will equal 0. 4 squared plus 4b minus 12. 0 equals 16 plus 4b minus 12. So 4 plus 4b, so you can just see b is minus 1. And then you can confirm this. You can go x squared minus x, because b is minus 1, minus 12. You can factorize that, and you'll see that it's x minus 4 times x plus 3. And it is a factor. X plus 3. Okay, easy marks. Now, this is a good question here. So we'll go through the parts. Find the value of this. Okay, so that's easy enough. It's just the scientific notation. I'll catch people out. So it's e to the 9 times 1.2. You type that into your calculator. You're going to get 4902.80 here. Scientific notation then is 4.902080 by 10 to the 4, because I moved the decimal place in here 4 steps. 1, 2, 3, 4. And then to one decimal place, it's 4.9 by 10 to the 4. That's the answer. Okay. Find the value of x for when g of x equals 3.5. Give your answer like that. So g of x is 3.5. So 3.5 equals ln root x. So what you do is you move this out of log format. So the base here is e, so the base will still be e. The 3.5 will be the power, and then the thing inside the log will be on its own over here, which is root x. So then x, you square both sides, so x equals e to the 3.5 squared, which is x equals e to the 7. That's the answer there. And then the last one's a good one. You put your f of x inside your g of x. F of x into g of x. So g with f of x inside of it is ln root e to the 9 x in for x. Now what you do here is you realize that that's a half. That's the power of a half. So the rule is that that becomes e to the sort of 4.5x, if that makes sense, because that's the power of a half, and your half will multiply by your, because you know it's e to the 9x all to the power of a half, and then the powers multiply. So you get yourself 4.5x. Rule of logs is that thing pops out the front. And then you get ln e, and ln e is a value of 1, and so the answer is 4.5x. Why do I have that there? Yeah. So it's 4.5x, yeah. So then you'd write it then as well as 9x over 2. Probably a bit neater. Yeah, in terms of x, so you see the x is still there, so 9x over 2. Right. The long questions. So there should only be 3 of these, but there's 4 of them. Sure. That's the way it is now. Very easy question here, sort of junior cert stuff. Tax, so we work out the total tax paid, so it's 40,000 times 0.2, plus the excess, which is 54,000 minus 40,000, and we tax that then at 40%, and we take away our tax credits, and that works out as, I'll just double check, plus 14,004 minus 1775. Yeah, so that works out as 11825, and you then take that number away. So this is his net pay. That's the net tax, and then the net pay is that number. Take away that number, his gross salary, and you get 42175, and make sure I put a euro symbol there. Sound. Okay, next one, interesting question. So this here, very important. You need to always be able to write out your series. Never mind that amortization formula in your tables book. Shouldn't be using it. Right. So the idea is here, these people have a mortgage, and they make these payments. These are all future payments, because the present day is the day when they take out the mortgage. So this first payment, which occurs a month later, is in the future. And you need to see what that future payment looks like today, which is its present version. And present values look like this, with their future value over the 1 plus I to the t. So the present value for all of these, the first one, this first future value, brought back to the present by 1 month looks like this, 1.00279 to the 1. The next future value, which occurs 2 months in the future, brought back to the present day, looks like this, 0.00279 power 2, and then the last one like this. So it said the first 3, didn't it? Yeah. Okay, easy-ish marks, if you know your stuff. Now, the next thing down here is work out the total amount of the mortgage. So I'll delete that there. And then this goes on, they said for 25 years at the top there, it said 25 years. So dot, 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 the last payment, which is 1647.75, all over 1.00279 to the power of 300 months, 12 by 25. So in this scenario here, it's an SN formula. There are n equals 300 terms. A equals the first term there, 1647.75, and then n or I've already done n, so r equals 1 over 1.00279. So when you sub this into your SN formula, SN equals A times 1 minus r to the n over 1 minus r, so you know that it's in your tables book. So on top here, you're going to have the A, which is, oh, that's not right. So your A is this thing here, has a thing on the bottom. This here, I'll circle it, that's your A. Okay, so I'm subbing in my A here, 1647.75 over 1.00279, bracket 1 minus r, 00279, to the power of 300, like that, and then it's over 1 minus r, which is 1 over 1.00279. Now I'm not going to bother typing that into a calculator again. Again, you don't get any more marks for multiplying that out. That's a number there in pink. That there is in red. Then the thing above it, there's a red part. That's not part of things there. That's part of my A up there. And then if you type that in there, you'll see that their mortgage was 334,562.62, and then you round that up to 563. Put the euro symbol in. Okay. Right, via puts that's fine. That's fine, yeah. So puts money in a savings account, number of years. So it's kind of a function here. Use differentiation to find the rate of change of the money after 3.5 years. So you just need to know to take a derivative of this. So f dash t is equal to 5,000. The 5,000 does nothing, so it's just this guy. This guy, when you're differentiating exponentials like that, they stay the same. They're the exact same, and then you just multiply by the derivative of the power, which is 0.04. And then you put in here 3.5. 5,000 times e to the 0.04 times 3.5 times 0.04. You type that into your calculator, you get a value of 230.05, and the units for that is euros per year, because it's the derivative. It's money per time. So what this says is at that given instant, it looks like the amount of money in the savings account will go up by that in the year. That's only an instantaneous rate of change. It's not an average. Right. Use integration to find average amount of money. So that's the average value formula. So it's this, your average value, you call it AV, is equal to, your 1 over your b minus a integral from a to b and of your function, like such. So that's the formula. So then the average value here, AV call it, equal the integral for the first 5 years, so 0 to 5, of this function. Now, 1 over 5 minus 0 out the front. So that's a fifth, and then in a square bracket, we'll multiply by the integral of this, so I change it to a straight line like this, and the integral is e to the, it stays the same, and you just divide by the differential of the power, like such. And then that becomes a fifth out the front in a square bracket, multiplied by in here, when you put the upper limit in, which is 5,000 over 0.04 e to the 0.04 times 5, minus, when the lower limit is in, 5,000 over 0.04 e to the 0. And close off your brackets like that. So again, that's full marks. All the numbers are there. And then you just type that into your calculator and you get a value, an average value of, I got 5,535.07 euros. You can round that off then. Okay, that's fine. Work out the AER. Yeah, it's a good question. So usually the future value looks like 5,000 times, your 1 plus I in here. And you'll have your T here. So what's happened is this part of it here is, and I'll write it like this as well, and then I bring the T out like that. So like I could just multiply, the rule of indices, you can just multiply them back together to be that. So I'm just rewriting my F like this here. So that's F. That's just basically the F up there, but I've rewritten it like this. And then if you just compare it, you see that the 1 plus I is equal to this. And you type that into a calculator, you'll see that 1 plus I. No, what I actually done was I took away the 1 first. So then I equals e to the 0.04 take away 1. And I typed that into my calculator. And I got 0.0408. And then that means I was equal to 4.08% to 2 decimal places. Done. Good question that definitely took a bit of thinking about. Not everyone would have got it. It probably would have been worth 10 marks. Sound. Right, this thing here, very easy. Fill out a table here and draw a graph of it. So I'm not going to label this. I'll read out the values. 6, 43, 62, 69, 70, 71, 78. And what's happening is it's kind of aggressively growing, then it's flattening out, and then it's about to kick off again there again. It's going to grow rapidly again. And you can plot that in Desmos as well if you wanted to see it. Right, this is the bulk of the question. So we have a cosine function here. Few things about this as well. The period of this function is 365, but you can kind of see that in the thing. Its range is its minimum value would be 2 and its maximum value would be 40, because it'll have its minimum value when this fella reports a value of -1. And there's your 2. And it'll have maximum value when the cosine reports a value of +1, which is the 40. And then that's the answers here. Now, I don't think there was any units given in this question. So, not euros. I think it's just like number of sales per day, how many things are bought or sold. Sound. And the equation of the midway line then would be 21. But that was NAS. They were really just checking. This was just a weird way of saying what was the range of the function. Now, this thing down here is a little bit more involved. They said there's this new function called CAT, and it is the original function with a little bit extra attached on. So they're like, when does SAT and CAT give the same value? Give the same number of sales, and SAT is the number of sales, and so is CAT, number of sales. So you just set them equal to one another. So you go with your SAT, your CAT here, which has SAT in it, so I'll actually write it like this. So minus 2.4. So this is, I'll just write it here. So this is when SAT equals CFT. And I'm writing my CFT here. Yeah. And then that equals SAT. But sure, there's SAT on both sides, so you just cancel it. Take it away. And then it's just this thing equals 0. So it's minus 2.4 plus 0.03t equals 0. Bring the 2.4 over, divide by 0.03. You get t equals 80 days. So it's an interesting question for sure. This one here, what is this? SAT. So I'll write out what CAT is here first of all. CFT is the SAT from above. Where's the D? Here it is. So 21 plus 19 cosine this thing 2 pi t over 365. Take away 2.4 and add on 0.03t. Now, this here is a cosine. It has a cosine in it, so it's definitely not this function. It couldn't be a straight line. It's also not this function here because of this part here. This is the main part. So as t goes along, this thing is getting bigger as t gets bigger. So what that affects is sort of the midway line. So this guy that I'm circling here, he'll always have a value between 1 and -1, which is sort of what this guy will do. But his midway line at the minute is 21, so he'll normally bounce up and down here from 21. But because this value is getting bigger over time, the midway value is getting bigger over time, and that's why she's slowly getting bigger like that. So you could just talk about the fact that it's this value is getting bigger over time, and so the midway line that's there doesn't stay constant. It's sort of shifting upwards like this, and that's why it's L. So basically, the examiner is just looking for you to talk about this value here and how it makes C of t bigger over time, and the cosine is not allowed to oscillate around a constant value getting bigger. Right, the derivative here, you didn't have to work it out. It's given like this. Find the first local maximum. So yeah, so this was the only really tough part here. Well, yeah, it's the only really tough part. So what you got to do here to find maximums is you set this guy equal to 0. It even told you that, which it shouldn't, but it did. So you set him equal to 0. So this is a common question that's come up loads of times when you're finding solutions like this to trig functions. So you set him equal to 0. 0.03 minus 38 pi over 365 sine 2 pi t over 365 equals 0. Move it around to get the sign on its own, so you'd bring him over the other side. He'd be minus 0.03, then you drop the minuses, and then you'll multiply both sides by 365 and divide both sides by 38 pi. And so I'm sure most people will be able to do that. So what I'll write is just the sign on its own on the left side, and then it's equal to a value of 0.1089, 4 decimal places would be loads, but I kept 6 here for a bit of accuracy. Now, this sine function, they're a bit like quadratics. They always give 2 values, so you need your CAST diagram for this, C-A-S-T. The sine is equal to a positive number, and the 2 places sine are positive is first and second quadrant. This quadrant is known as theta, and this quadrant here is your pi minus theta. So what you do, because we're in radians as well, you just take a sine inverse of that, and the first scenario, let me get a different color for this. The first solution will say that the inside of that sine equals sine inverse of this thing. And the sine inverse of that thing there, so the sine inverse of 0.108922 is equal to 0.10914. So you can just set that equal there. This is the first solution. Now there's also another solution where this thing, which is theta, when you go sine inverse this thing, you get your angle, is equal to pi minus that angle there. And because you're in radians, it looks like the angle looks like that. So this is over 365. The left is the same, and then this side here is just pi minus that. 10914. So a lot of people would only got this answer, and as you'll see in a sec, this is actually the wrong answer. So here what you'll do is you multiply across by 365 and divide by 2 pi. When you do that, you get 6.34 days. What you do here is you multiply by 365, divide by 2 pi, and you'll get 176.16 days. Now, one of them is a minimum and one of them is not. To know which one is the min or the max, you need to do a second derivative test. C dash t, you work it out. Now I have it worked out here, it's a messy thing. Minus 38 pi over 365. You take a derivative of that, sine becomes cos, you know. And then that's multiplied by 2 pi over 365. And then it becomes cos 2 pi t over 365. Now, when you go and put the first value in, which is what the only value that most people would have got, you get a value, very small value. It's like 5.6. It's minus 5.6 by 10 to the minus 3. And that's negative, which means it's less than 0. And then if it's less than 0, it's a max. We don't want a max. If you put the other one in, 176.16, you get the exact same value, but it's positive. And because it's positive, greater than 0, it's a min. And that's the first local min. It actually is looking for a local max. So that even makes things easier, doesn't it? So then that's the answer. Yeah, very easy exam at the end of the day. So yep. Okay, yeah. Yeah, fine, gives the local max, yeah. Sound. Okay, so that's your answer. We'll clear that away. So question 9 starts off pretty handy. You're subbing some values in to get a volume. C equals pi times 4 squared over 3 bracket 3 multiplied by 13 minus 4, which gives 560 pi over 3. Was there any units given for this? I don't see any, so you just leave your answer like that. There's a different shape then, and it has instead of k being 4, now it's y, and the radius is 8. So you just sub into that formula up there, and you replace c then with the volume given. So it's 36 pi y equals pi k squared, now k is called y, over 3 bracket 3 times 8, because r is 8 now, minus y. And then your pi's cancel like that, and then your y cancels with that 2 there, and you're left with 36 equals y over 3 bracket 24 minus y, and that's what they want. Very easy. Now multiply this out and solve it. Again, very easy. Just being aware, y is less than 8, so that will come into it here in a sec. Multiplying this out, I'll multiply both sides by 3 and multiply it out, so I get 24y minus y squared equals 108. Bring it all to one side, y squared minus 24y plus 108 equals 0. You can factorize that, or you can use the minus b formula. The factors are y minus 6, y minus 18, I believe. 0. Yeah, 6 by 18. Yeah. So the solutions are y equals 6 or y equals 18, but as I showed you, that's not allowed. Y has to be below 8, so the answer is 6, and I don't think it has units again. So if it does, put in the units. Yeah, just call units, so not like centimeters or anything. So there's a hemisphere now, another shape. Now, careful. This formula requires 3 cms cubed. So a lot of people would have messed up here, for sure. So what you need to know is that 1 liter, or sorry, in a meter cubed is a huge box. It's like a huge box, and into that you can get 1,000 liters. That's the way I remember it. So that's the first thing. Now, what we have to realize is that how many meters cubed or how many centimeters cubed is in a meter cubed. So this is the idea. 1 centimeter cubed is actually equal to 1 by 10 to the minus 6 meters cubed. And where that comes from, centa is 10 to the minus 2. And because this is a three-dimensional thing, there's 3 of these. So it's like 10 to the minus 2 by 10 to the minus 2 by 10 to the minus 2. So that's where the 10 to the minus 6 comes from. So that's why that's a very, very small number. So a centimeter cubed is only a little cube, and that's why it's such a small amount of a big cube. Right. What we need then to realize is that 1 meter cubed is equal to 1 by 10 to the 6 centimeters cubed. So there's 1,000,000 centimeters cubed in a meter cubed, which is then 1 meter cubed is 1,000 liters. 1,000 liters equals 1 by 10 to the 6 centimeters cubed. So 1 litre then, that's 10 to the 3, is equal to, you divide 10 to the 3 by 10 to the 6, and you're left with 10 to the 3 centimeters cubed. Now, some people might have known that a litre was 1,000 centimeters cubed, and if you did, that's great. You'd have had no issues with this, and so you'd have realised that 3 litres is 3,000 centimeters cubed. Okay, so what we do here is we set not 3, we set 3,000 equal to pi over 12 x cubed. Multiply across by 12, divide by 3, and take a cubed root, and your x is equal to 3,000 times 12 over pi all to the power of a third, which is 22.545, and it has units of centimeters, diameters in centimeters. Cool. That was a tough one. Now, this is a rate of change question. Volume of a hemisphere is increasing at this rate, so you read that very carefully, you study its units, and you realize that what they've just told you there is dv dt, and that's 450, and it's increasing, so it's a positive value. Now, find the rate the diameter is increasing with time. So the thing you're looking for here is dx dt, and you put a question mark beside the thing you're looking for. Dx dt. The thing you're looking for, then you pull apart like this. So dx dt, this is the way these questions always go down, huge repetition involved. The dx has to go there, the dt has to go there, and it makes sense based on what we're talking about in this question to put dv here. You can put whatever you want there, but we put dv there. So we know dv dt, so we just need to multiply it by whatever dx dv is. Now, from this function, we can get dv dx, which is multiply down by 3, and it'll work down as pi over 4 x squared. So then dx dv is 4 over x squared pi, something like that. And you sub it in here, then you get your 4 over, and x has been set as 20 squared pi multiplied by 450. Type that in again just to make sure. 4 multiplied by 450 over 20 squared multiplied by pi, and the answer for dx dt works out as 1.432, and the units are centimeters per second, but they were nice and they actually told you that. And then it'll be 1.4 when you round it. Sound. That was a reasonable one. This here's reasonable enough as well. The student just needs to know how to start it. We start off with s in terms of the other guys, and then we want to get h on its own. So what you do is you square both sides, and you just got to be careful that these guys also get squared here. So s squared equals pi squared or squared, and now the square root goes away. So maybe some people would have messed up there and not squared those two. Now, what you want to do is divide by this thing here. So then you get s squared over pi squared r squared, and then that's equal to your r squared plus your h squared. Then you take away your r squared to get your h squared on its own. So h squared on its own is the s squared over the pi squared r squared. Take away the r squared. Now, you need to write that as a single fraction because that's its format there. So you'll multiply this guy above and below by pi squared r squared, and then that'll make your h squared. Write it over here. Your h squared will look like s squared over pi squared r squared. This guy's been multiplied above and below by pi squared r squared, so he becomes pi squared r to the 4 over pi squared r squared. And they're the same denominator, so I can write them like such. I'll take a square root. H equals, you'd need to go plus and minus, but h is positive, so no need for the plus and minus. You take square roots, you have to go plus and minus normally. On top, you have s squared minus pi squared r to the 4. And then on the bottom, you have pi squared r squared. You're not allowed to take a square root at the top, but you can on the bottom. And so your answer is root s squared minus pi squared r to the 4 all over pi r. That's your answer. Okay, all right, move on to the next one. The last one, thankfully. Right, so we're on to the last one. The last one's actually pretty nasty. The first two are super simple, so people will be like, yeah, this looks like an easy one. So you get drawn in with these first two. First one is very simple. It's just like you let x be 15, so you can read it there. W15 equals 0 0.667 times 15 plus 1.5 times 15 squared minus 0.025 15 cubed. So again, like you get no more attempt marks. Just writing that number there is nearly all the marks for the question. You just pick up your calculator and try and write things correctly into the calculator. And then when I wrote that in, I got, 263.13 millimeters, which is 263 to the nearest millimeter. Write down the derivative, this is very simple stuff. So the question takes a turn to become a bit harder after this. 0.667 plus 3x minus 0.075x squared when you multiply down by 3. That's your answer. Okay. That thing actually has units as well. I don't know, will they mark people on the units? Its units are millimeters per day. I don't think they will mark people on that, but it does have units. Yeah. Okay. There's another function for another plant, and this is your p-x. So this is something that's in the algebra chapter. It's they're called quadratic inequalities. They're inequalities because they have this sort of greater than symbol here. So you just take this function. So again, these are in the textbooks. They're a very common question. If you practiced it, you set it greater than 24. Now you bring everyone to one side. So I'm actually going to bring everyone over to the right side. So everyone is going to be pointed at, the tip will be pointing at everyone. So when everyone goes over to one side, they'll be 0.078 x squared minus 2.73 x. The numbers combine together to give plus 29.9. Remember I said they're getting pointed at, the tip is pointing at them like that. Now, you use the minus b formula on this to get your x's, but these aren't your answers, so I don't know, you mightn't get all the marks if you think this is the answers. 2.73, you definitely won't get all the marks. Plus and minus, so minus b square root 2.73 squared minus 4 times a, which is 0.078, times c, which is 29.9, over 2 times a. So then you get two values for this, so x works out as 21.058 and x works out as 13.942, and they said to the nearest whole number, so it's 21 and x is 14. They're not your answers. The solution for these, and you can learn them in your textbook. Yeah, they were in the textbook, a few of them. So you mark 2 dots on a number line like this, and then you mark the first one, which is a 14. You mark the next one on the number line, which is a 21. This quadratic here is a U-shaped quadratic because the x squared is positive. And because it says the function, all of this in pink, is to be less than 0, we shade in the part underneath the number line. And so the solutions are x is less than 21 but greater than 14. And I have that drawn up in Desmos, I'll show you. But that's the solution there in pink, so I'll clear this away. So this here is our solution. That's the function we were working with. This is 24, which we're talking about. And you can see that the function is only above 24 for a short while when x is bigger than 13.94, which we worked out, which is the 14, and when it's less than the 21. Cool. So back here we go. Right, this here was tricky enough. Well, the integration isn't. Sure, they make it very straightforward how you integrate this. You're to get the area on the right and then double it. So you just need to get the area between two curves, which is this pink area here. And the way you do that, the easiest way to do it, is you first of all subtract the two curves. So you take the taller one, which is this one. See how this one's taller because its y value is always higher than the lower one. You take the taller one away from the lower one, and then you integrate. So I'm integrating, and you know your limits as well. They didn't have to give you the 1. You could have worked it out yourself. They made this question pretty easy. 0 to 1. And the taller curve is called s of x, so that's 2x minus x squared, take away the lower curve, which is called x squared. Dx there. Okay, and then you double this because we want the two areas. So I'll put a little 2 on the outside there to double it. So the answer is 2 multiplied by a straight line here with the 0 and a 1. You integrate this here. Them together they're minus 2x, so I'll write that here. So this is 2, 0, 1, 2x minus 2x squared dx. Okay, straight line now because I've done the integration, and when they get integrated become x squared minus 2 over 3x to the 3, and then that equals 2, square bracket, and you're putting the limits in. So I'll put the 1 in first, so it's a 1 squared minus 2 over 3 times a 1 cubed. Take away when the lower limit's in, which is just 0, and you get an answer there of 2 over 3. Yeah, you get an answer of 2 over 3. That's the area of the shaded zone there. This is tricky. You either know how it works or how it doesn't work. Axial symmetry through the y-axis. So when a function flips through the y-axis, the way it's done is you replace all your x's with minus x's. So wherever you have an x, you just replace it with the minus x. If you wanted to flip your function through the x-axis, you just put a big minus in front of everyone because that's y. So you like put a minus in front of your y. So k of x is literally s of x, where I just go and isolate all the x's and put minuses in front of them. Minus x minus x squared. And then I'm going to tidy it up, and it gives minus 2x minus x squared. And so when we scroll down here to give it in the format that they want, that's k of x there. So it has no c, there is no constant. So c is 0. A, which is minus 1 as it is, and then the b is minus 2. So yeah, it's either something you knew or you didn't know, is that you do the minus x thing to mirror it through the y-axis. And I have a graph of that done on Desmos here. Cool. So you can sort of see it there. That's the function that we just got there, and then that's it mirrored over. Cool. Right, that's that. The last one then, last question on the paper. Easy enough. A little bit of words, a lot of words here for sure. P is the usual price of the bag. So option 1 is we take the usual price, reduce it by 10%. So when you reduce something by 10%, the new value is it's sort of just multiplied by 0.9. Okay. So when you take 10% of something, the new value is just the same value by 0.9. And then we reduce it by r, so you take away r. So then that works out as price 1 is 0.9p minus r. Now option 2 is we first of all reduce the price by r. So the price here is p minus r, and then we reduce that new price by 10%, which is again multiplied by 0.9. And then if you multiply that out, you see that that's 0.9p minus 0.9r. So which is better? So this here is sort of a fixed number in blue, and we want a small, cheaper price. And so we'll want the biggest amount cut away from this, taken away, and we want the full or to be taken away for a good price, whereas if we only take away 0.9 or, we take away less. And a way to think about that, so option 1 is cheaper. It's cheaper. And a way to think about that, if or was 10 euros, what we would be taking away here is 10, whereas here we'll only be taking away 9 euro. So you want to take away as much as possible, so you want to take away a full or. So yeah, that's that. Okay, so that's the end of that paper. Hope it went well for everyone. Okay, thanks.